Hey guys, what's new? There was a request for number 3 on the quadratics projectile sheet, so I wanted to do that for you guys. And good news, we got a new printer, so now I can actually print out the worksheets and work them. And I got an ugly pen, so things are looking up for me. All right, so number 3 says a rocket is launched from atop a 101-foot cliff with an initial velocity of 116 feet per second. Substitute the values into the vertical motion formula. So this is actually the formula for vertical motion, okay? So this is any motion that goes up, you can measure it as a quadratic. There's a separate and different formula for horizontal motion. And if you were to say like shoot a rocket off at an angle, all you do is just kind of put these two equations together. So right now we're only dealing with the vertical motion. And like I said in the intro of the other video, this is velocity. So this velocity is going to go right here. And then this is, and this pen is awful, position. So this is the position. This is just called HO and VT. This is the velocity of time, and then this is just a constant. It's just the position it starts in. So it says substitute the values in. So it's going to be h of t is equal to negative 16t squared plus v of t is 116 t. And all I'm doing is putting in this, and I need t because it's based off of time, okay? And then h of o is the position, and it starts at 101 feet, so it's going to be plus 101. Now it says let h of t equal 0. What does that mean? Well, that's this. This is h of t. That's the height of time. And the reason you set this equal to 0 is because whenever you're going to solve it, you're going to set it equal to 0 to solve for when the equation equals 0. Remember that when you solve your quadratic, y is equal to 0 is where you have your roots or your solutions. Sorry. Where y equals 0 on your x-axis is where you have your roots or your solutions. Okay, so 0 is equal to negative 16t squared plus 116t plus 101. That's the equation you're going to use. And from here, you can either use quadratic formula or you can try to factor it. How long will it take the rocket to hit the ground after it's launched? I believe I used the quadratic formula for this. If you remember, the quadratic formula is negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. And then we're going to plug in. So I've got negative b is negative 116 plus or minus square root of 116 squared minus 4 times a times c all over 2 times a. And all you gotta do is solve for that. There's gonna be 2 of them, okay? And the reason is, if you think about what c is, this c is the height. It's gonna start up here at 101. And so the rest of your parabola is gonna be a negative number. And where it hits the ground is gonna be the positive answer. Okay, so whenever you have a quadratic equation, c, the number out back, that's your y-intercept. Okay, what else? I thought that would also answer number 10 because number 10 looks like the same thing. And I wanted to talk about number 15 real quick. Number 15 says, during World War I, mortars were fired from the trenches 3 meters down. The mortars had a velocity of 150 feet per second to determine how long it would take for the mortar shell to strike the target. Okay, it doesn't give you very much to go with, but you have to find the pattern. So remember, the first thing with x squared, this is going to be acceleration. And the only thing that's accelerating here is the acting of gravity. And so if you look, every single one of the problems has negative 16t squared. So anything has negative 16t squared when you're dealing with time. And then it gives you the mortar velocity. And then since we're firing from 3 feet down, it would be -3. Okay? And then you just solve from there if you want. Okay, hope this was fun. I really think this is application to real life, and I hope you guys find this challenging but somewhat enjoyable. Have a good day.